edasi ja järgmiseks ettekandjaks on Heikki Tapani Keskituru, esitab Eesti Lennuakadeemia ja teemaks on arenguperspektiivid lennujuhtimises.
Okay, my name is Heikki Tapani Keskituru and been 3 years here teaching becoming air traffic controllers. Background is more than 30 years in ATC, some piloting, and my presentation is not only ATM, it is from aviation. I consider myself as well a controller, but as an aviator. Let's go. So I have divided this in 3 parts. One is the ATC part, second one the UAV, and overall aviation. There might be possibilities for companies in Estonia for all these branches. Okay, about the background of the ATM, what is happening in today's world. It's a congestion. The amount of the passengers, amount of the aircrafts are growing. And we have a big problem in the future when the Asia is starting to grow even more than it is doing today. So Beijing will be the biggest hub in the world. 2018 they are having a new airport which is capable of handling 1/4 of Estonia citizens in one day. And where they are coming, where they are flying, quite a lot of want to fly to Europe to see Eiffel Tower and so on. And this is something which explains what has happened in China last 20 years. There is a picture from Shanghai. There is a Yangtze River, and it has been divided in 2 parts. So 1990 and 2010. So that's what is happening in there. Okay, still, as it was well said in the previous lectures, that the ATC is really conservative. That is as well that it is guaranteeing the safety. We are always keeping ourselves safe. But still some of the equipment's methods are from 1950s. For this one example, see and avoid in a VMC, meaning that the aircraft which are flying below clouds, mostly private aircraft, they are keeping separating themselves by just looking out. They have to see out and then they have to avoid other traffic. And they are same kind of traffic rules as we have in roads, that from which direction aircraft is coming and who has to then give away. There are big projects going on. Cesar in Europe, Next Gen in the United States, which is quite much the same size as our Cesar. We are doing quite much the same work. And that is really good that the cooperation has started between these big, huge projects, that we are not making our own products, our own systems, so there is a cooperation going on. But these projects cannot cover all. They are big master projects, and there are plenty of things which are still in, let's say, in ATC, which nobody is not even thinking. Okay, we can basically skip this. So information, integrate the information from different sources. That is the main thing which is happening in the future. And this is one example what is happening today already. That there is a flight from Middle East to Brisbane, Australia. And that blue line is the direct route, the Great Circle route, which is the shortest distance between 2 positions in the world. And the red one is the one which is actually happened. And with that flight, when it took the preferred route, the savings were 8,400 kilos of fuel, meaning that they saved 20,000 tons of carbon monoxide on that. So that's the life which happens. We can't anymore predict that if flight between 2 points in the world, they are always flying over Estonia. It depends the atmosphere. And these routes can be changed during the flight. And it's amazing that almost 7-hour flight, the biggest distance between the shortest route and the selected one was more than 1,000 nautical miles. Okay, we have already had talks about the delegation of separation, that responsibility to keep the aircraft away at appropriate distance away is delivered or delegated to the pilots. And there are different steps on it. The meaning for the ATM is to reach the full delegation, meaning that autonomous flight, the aircraft can fly basically where they want, wherever they want to go. Okay, already now during the CESAR and Next Gen search, it has been defined mission impossible. There will be some rules which are linked to these flights, although they are flying in the free flight airspace. This limited and extended delegation can be reached much earlier than this full delegation. So, delegation needs new equipment in the cockpit and requires new tasks for the pilots. This is still an ongoing question, that are pilots capable of doing it in a really busy situation, busy airspace? Separation is now done with ATC. Can the pilots and the FMS take the responsibility? There are simulations ongoing on this, and lots of opposing discussions from pilot side that they are not really willing to take at least so much as the free flight requires. There is an example what the pilot can see, this CDTI. And there is an aircraft which is flying presently at flight level 380, and system detects that there is an intruder at same level. So this is giving an instruction that before this point, over here, you have to reach flight level 410, and to reach that you have to climb at vertical speed 1,170 feet per minute. This kind of equipment definitely will be, and separation will be delegated for the pilots, but the amount can be something that not yet defined. Okay, I think we can skip these. So as I told that, although there will be a full free flight scene, that means that when the aircraft is departing, let's say from Estonia to Portugal or Lisbon, the FMS is making a contract with the flight, the traffic, some kind of center, maybe a center would be, so that the ATC computers know where this aircraft will be, at what level, on what time. And always when the aircraft is getting out of this contract, it has to be renegotiated. So always the system knows that at time T1, this aircraft is in this area, and at time T1, this aircraft is in this area. And then the systems are knowing that there will be a conflict somewhere. So basically, if you are thinking of this picture, there is a larger bubble inside the aircraft has to remain all the time. It is carrying this bubble along when it's flying. And it has to remain in this side, in this bubble. When it's getting out of this, it has to start a new negotiation with the system. Okay, freedom bubble is something that it can move freely basically in this if there is a need. If there is a big cloud in a CP cloud, they can even climb to avoid it or avoid it left to right, whatever. And the safety bubble is something that inside that there shouldn't be anybody, or then there has to be instructions to do and avoid it. Okay, so today's problem is lack of information. The air traffic control systems we are not thinking about the aircraft which is departing now to Tallinn. We are starting to think, Tallinn is starting to think when they are coming from the neighboring countries. Then we are really knowing where it will be and what is the flight level and what is the route. So the planning window is really relatively short. And that is one reason our systems are really limiting the traffic increase and the possibilities to do the great service in ATM. But what is tomorrow? My prediction is that as far as I have seen these proposed systems which will be in use in the future, that the air traffic controllers as well pilots will be overloaded with information. Today we are lacking, and the first proposal what has been available, that there is too much information. Same thing is happened with the mobile phones. How many of you can really use your mobile phone, all the functionalities in it? There is a huge amount of things we don't have any idea. And that might be the future in ATM. So, this is an end result when German Tornado and Volkswagen are colliding. And this is the one where we should do the work and to make the ATC and the controlling more safe. And this is the tool which is planned to prevent it. And first steps already are in use in Tallinn and Helsinki, but there is still plenty of things on that. But I'm not really willing to talk anymore about. Let's go. Remote tower we passed a few times. So actually there is one remote tower already in operational in a really international airport. On Heathrow, they took contingency tower in operational use 2012, meaning that somewhere in London, they are not even telling the position of it. It's not at the airport or can be at the airport, somewhere. It's really when the terrorist, let's say, threat was really high, they started to think that how about if the attack happens at the airport, and what is the most obvious place to attack? It's that glass building, poor controllers there. So they built up a remote tower, which is, they say that it's operational and they are planning to have at least 50% of the traffic what they are doing now from the standard tower. One thing in the tower is this virtual tower, which was in Uller's presentation. So giving tools for tower controllers in a degraded visibility. And there is an example that what can bring, what are the tools. So some kind of system which is showing, giving the camera pictures and making a view on the glass, the windows, the air traffic controllers are really looking through. And giving information about the aircraft themselves. So we can have the same kind of data block we are using in the radar. We know the call signs, we can see the speed, altitudes, we can even see that what is the status of the flight, has it got the landing clearance or not. So this is now ongoing project and maybe in the future. This is one example about the new virtual tower. This is based on a little bit more traditional technique. So by using camera, controllers can see, in this case it is a bit foggy. They can pick up, in this case it's ATS ATR42. So if they really want to see an aircraft on stand somewhere, what is happening. So this is something we can do already with today's technique. I'm now giving a few examples from my background about the possibilities, how the ATM, ATC and the enterprises can work together. This new tower in Rovaniemi, is old and new one. Became operational 2008. I was a chief controller there while we were building it up, and I was quite much charged of the project itself. And as you can see, we have winter and springtime. There is lots of light. So from the spring snow, the reflection can be something like 80% of the sun. So we can have 100, instead of 100% of light, we can have 180. And we made a risk analysis before starting or during the planning process, and idea is to make all the work, media, all the how we are controlling the airport equipment, lights, all the things. We plan to take touch screens, and touch screens and that kind of light, amount of light, mission impossible, because you couldn't see anything on that. Go outside in the sunny day with your laptop, you can't see anything. So we started to figure out what to do. Actually, I found already 2007, I found an American company who is making electronically the machined glasses that you can shade or control the amount of light by electrical waves. And I contacted them, is there available those kind of glasses, we like to buy them. And they say that they can make, let's say, 1 meter by 1 meter, that's the maximum. But that might be the future, that you can just dim your windows by a button. Okay, next step, we had to find out the good glass. And we contacted Pilkington in Lahti in Finland, and then Dr. Taho Sutela. He is really professional to cook glass, what to put in the kettle when they are making it. And we created a new tower glass of amount of light which is coming in is 43%. So 57% of the incoming light it is taken away, and all the other radiation, just a small part of heat is coming, 20% of the heat which is outside. And it sounds really terrible that how come we can cope with the winter time then? But we make experience, and Taavo explained that human eye is a really adaptive thing. That you can't really you can't say if you are inside our tower that you are getting only 43% of the light in. Your eye you can't take it. And then one good example on this, that these electronic glasses where you can control the light in, they are already in operational use with the new Boeing 787. And Airbus, when they were inventing the new 350, they decided that they are not taking that glass. And the reason is that you can't shade 100% of the light. Today's projects or products, 1% is still getting through. And that is too much for the passengers. So they selected to have this all kind of shade. So one thing is the cameras, what definitely will be in the future towers. And again, I say that the information will be too much in tomorrow's products. So how come air traffic controller on top of other tasks is starting to control cameras to zoom or select? So this is one product I think that might be possible. I haven't seen it in any remote tower concepts, that you should start to give commands for these cameras on voice. Seek runway, or check runway, meaning that the camera is checking the runway, having infrared and visible spectrum. Is there anything? Or seek Saab 340 on stand 5, follow it when it's starting to move. So you can see on the picture that somebody's moved. So these kind of things, not to have a camera set and you are driving them on top of controlling, but give a command and let the system do it. This is one example where it's not in a sari, it's coming outside. This is happened this year in Italy. ATR working under Alitalia colors, Carpater, had an accident in the middle of the airport. And it took more than 10 minutes for rescue persons to find it. ICAO standard is that in any case, if the accident happens inside of the airport fence, the rescue personnel should reach the site within 180 seconds, 3 minutes. And as you can see the route, there's the accident site. That's the way where the rescue people or the vehicles came in. They were driving this kind of route before finding it. So it was non-standard operations from the air traffic controller. The controller on duty didn't work as he or she should be. But think about, you have been working for tens of years and then suddenly happens something which is not normal. The human has to scope, human has to reach the level, give right, correct information for the rescue people, there is plenty of things you have to do in a short time. Okay, the rescue people didn't work as they should be. So it was human error. But when something happens really bad, human is the weakest link. Our mind is so blocked that we are not really operating normally. So this is one thing which might be a product for everywhere in the world. Make a tool for this search and rescue if accident happens. Meaning that there is an alarm system. There can be a picture from the frozen picture from the radar screen from last few minutes, which is pointing out where the aircraft stopped. There can be additional information about the aircraft type, meaning that the rescue people know that maximum amount of passengers is 355. So they know what to expect. There can be additional information on where is the wind blowing, because then they can plan already while driving on the site where they are starting to use their foam cannons and things like that. And so you are pushing a button which is sending an alarm for the rescue, calling all the rescue units in the city, depending on what is the aircraft type. So, and I think that if this isn't available, everybody is doing these kind of processes, things by themselves. Okay, about ATM. Service providers, the controllers, the people who are working in an ATM, they are the one who knows. They know what are the missing things, what they need. The problem is that the organizations, like I was working for Finavia, if somebody had an idea, the bosses said, don't worry boy, just do your work. So it has to be encouraged by the service service providers. But if somebody has a crazy idea, there has to be a system how somebody can pick it up and think of it if it's possible. Of course, there has to be resources. So there is if I compare, for example, Sweden and Finland, Finland and Luftfartsverket, we were always lack of people. If you were planning something new, there was no time for it. Luftfartsverket, they have plenty of staff. They have people who are really working for these kind of new innovations. And what they are gaining, for now, for example, the remote tower. Sweden is building remote tower network, and who is paying it? Not for Luftfartsverket, not for Saab. Europe is paying for them. We are buying them with our pockets. So that's the way they are doing. Their thinking is that. Okay, of course there has to be a network which is bringing up if there is an idea, to whom I should give it. Who should continue it? There has to be a method of doing it. The same, somebody asked that how we can find out things what are available in CESAR. It is in the internet. But how come if it is written on English and by used ABS on Latin? And if you are an IT guy, not any link with the ATC. It's really difficult to define that, hey, we have a product or we have an idea for that product. So there has to be some kind of combination of knowledge of the daily operational use, needs, and then possibilities which are available in the neighborhood. So there are possibilities for whatever for smaller enterprises within and outside of CESAR. CESAR is not covering everything. Okay, let's go for the next one. My favorite, UAVs. So they are already here. Military is using them, big ones, flying from United States to Afghanistan, controlled somewhere in the Middle West. Not talking about them. They are small things, already in operational use. Before getting in the house, a soldier is sending a small, which has a camera, safe to go. Okay, rule making, that's too late. We are too late for that. Now there are some light. European is taking care about the things which are 150 or greater. And now there is a definition that the local authorities can make rules for the smaller ones. That brings some hope. And I have a few things I would like to show you. About this.
Multiple views information.
Uh-huh. And they are doing three-dimensional also, so there is a pyramid surely. There will be a pyramid.
We developed the position between 3D. The team can navigate the environment.
Okay. I have to show the next one as well. Okay, we get this one.
Hello, my friend. That we watch this again. I've got something very, very special.
This is a scary thing in this UAV business. Okay, a bit action in the. This is the scariest part of this whole thing.
This is equipped with a self-destruct payload with a 15-foot blast radius. So yes, my friends, as much as it pains me, I'm going to blow this thing up. I want to thank my friend Yuri for letting me borrow his ride. Thanks, buddy.
Okay, as I say that there are scary things in this, but there is one more from France, Eurocopter from Israel. We can skip a little bit for this. Pilots started up the engines, got a clearance from ATC, and is leaving the helicopter. So meaning that today, for the modern aircraft, we don't need pilots anymore. There's no need. Okay, and then I put the last sentence in this is cyber war. It was amazing that the Israeli destroyed a few sites in Syria few weeks ago. And the Syrian, they had a really big army, plenty of surveillance, and they didn't do anything. And I read from a blog from one military aviator, quite, I don't know how well he was informed or not, but the most likely situation was that the Israelis sent UAVs before, and they somehow attacked the radar system of Syria, and then put the fighters or the bombers behind. So this is the reality with the military. How the things are going fast. First arrested landing 4th of May with a UAV. So there is a net meant for the carrier landings, which is stopping the system. 4th of May, the first carrier departure. So this is bringing the, let's say, giving the US Navy a possibility to go wherever and start operations wherever. From Europe, Spain, in San Xavier, they made a first test to fly a UAV inside of the normal ATC airspace. And they were really happy about the results. So plenty of things is happening in this. This is the Austrian UAV, and this is the same thing. So this is what I'm pointing on, that the UAV is a vehicle. The what which is hanging behind, that's the importance of the whole system. So the vehicles, the UAV vehicles themselves, they are tools, they are trucks. Different trucks are meant to carry wood, some gravel, whatever. So this is the business what the UAVs are for future. We only have to define that what are the two tasks they are capable of doing and where they are, what they are good. That can bring new kind of vehicles which doesn't exist yet. That can bring new procedures like the accuracy. Now we are talking about 30-40 centimeters accuracy. In the future it can be centimeters. Okay, we can skip this. This is one example about the project in a UAV. It was closed last month in Caesar. I just wanted to bring one Caesar project. That was only to create and demonstrate new technologies in 4 different subjects. And that was again joint work with the ANSPs, so service providers, air traffic control centers, safety, capacity, airport integration, airspace throughput, and security. And you just only have to find that your software, your tool is good on this, and you have to define that we can make it and do something which is aiming for the UAVs to be able to fly inside of the other civilian traffic. Okay. Possibilities for companies. So plenty of these things like power line checks. One good possibility in the future is the building bridge construction inspections. How we can do, for example, check on thermal camera where are the blockhouse, where they have the temperature insulation is not good enough. But if you have a tool which can be and carry about equipment can weigh about 20 kilos, accuracy is about 1, 2, 3, 5 centimeters, and starting to fly it like this kind of raster. That kind of software is already available for the tools, but there is not really a combination that you have a UAV or the Airbus and you should put these cameras and the recording system. So plenty of these kind of possibilities. Okay, machine is better than human. Unfortunately, it is in several cases. And for accuracy, I have to always bring this. EGNOS rims and ranging and inter-G monitoring stations. As you can see, there is Finland, Estonia, there's Lappeenranta, Kirkenes in Norway, and next one is Warsaw. And half of the Estonia is on the side that, for example, satellite-based approaches can't be done here because we are missing a rim station. And it's funded by European Space Agency, not the single dime is needed from here. Somebody has to just make a work on it. Okay, about aviation. One thing which is really fascinating is how to track passengers on the airports. Plenty of the airlines are putting all kinds of solutions on cell phones. That you have an electronic boarding pass in this and use that, go for the security and so on, so on, so on. And they have planned to put airport maps and instructions where the gate is. But your mobile can be off. Battery is flat. You have Nokia, you have iPhone, you have Android, you have whatever solutions. So, waste of time. There is a link if you want to see that. By having a tracking possibility for passengers, airlines are saving millions and millions dollars or euros annually, because there won't be so much delays for the departures. Airports can pinpoint the announcements. Mr. Bill, they can only send that section if they can detect that Mr. Bill which is lost, is somewhere over there. And if really needed, they can walk and say that, Mr. Bill, where are you? Your plane is leaving shortly, follow me. But they have to know where the passengers are. Okay, for passengers, of course, it's nice to have a guidance at the airport, you know where to go. But of course, there is possibility to find a shop, or even you can order a food where you are and they are bringing it to you. Airports, they can use for commercial purposes. They can have advertisements, they can have whatever. Really interesting is the queue management, because they can see that how many persons are waiting for security check, for example. So they can open new securities. They can see that now there are 1,000 people walking into the airport, we have to open new security. This is one solution which has been, it's in test in Manchester. This small chip on the finger, and have an original paper boarding pass, and it is attached on that. When you are walking at the airport, you can find where the person is. Of course, it needs new technology which is picking up that chip, but that's basically not really difficult. That has been done in Tartu Marathon for several years already. Of course, there are possibilities to have a information kiosk. If you have a chip, you put your boarding pass, it says you are here, your gate is there, you have 32 minutes time, do you like to have a drink? Okay, I prefer wine. Wine bars are there. These kind of things, but that doesn't exist. Okay, one thing is VLAN on the airplanes. We already get a little bit on it. It's one of the biggest growing businesses in aviation. The US cocoa, it's the gold mine. Former with AirCell. So it's already in more than 1,500 airlines and more than 5,000 business jets. So there are two different ways of doing it. One is from air to satellite, and satellite then to the ground. Okay, that is definitely needed for Atlantic crossing because there are no ground stations. And that has been selected, for example, for Norwegian in here, because we don't have the ground network in Europe supporting this. The COCO has in the United States 160 antennas. They have their own network, which is on side of the GNS. One thing which is really interesting, when the Wi-Fi started, they basically took the domestic Wi-Fi antennas and they installed those in the airplane. Okay, the result was that they didn't really work well because it is in a small tube. People were walking around. Now I read about that they have created some kind of a cable where there are slots which are picking the signals. But again, there is a possibility. Airlines, airport manufacturers, they don't like to have anything extra on the plane. Why about combining that Wi-Fi antenna, for example, that line which is going for the in each aircraft, the emergency light, which is under your feet. Make it in the antenna, so combine those two. Okay, one thing is in Europe, why not make an antennas which are capable of taking signal from the aircraft, and you have to of course think that it's flying quite fast, maybe I don't know. So, summary of aviation. New innovations are needed for future to make the possible growth to happen. Airports, terminals can't do it. There has to be more fluent transit through the terminals. Today, we have to be 2 hours before the international flight. So, if the amount of passengers is growing like that, no way. It should be less than an hour. So there has to be a possibility to check where we need and open those bottlenecks. Okay, so about ideas. This is a picture from Rovaniemi where I was working some years. There were 4 persons, early 1980s, and they have an idea that, how come? Let's bring one Concorde class of people from UK to see Santa Claus, and of course us beautiful Rovaniemi citizens. So they like more Santa Claus. So they started with the one Concorde flight. And this is what happens every winter. So that Concorde flight, which was a crazy idea, it started totally a new business. That's why you have to look out. Aitäh.
Kas on küsimusi? No nii, kas tõesti mitte ühtegi? Ei.
Thank you, Heikki, very much for extremely interesting and inspiring presentation. And I have one comment where I am a little bit related. I participated in an EU program which was devoted to free flight, actually, under the other names. And inside of this program, it was found that although the pilots will acquire much more responsibility and potentially much more information during free flights, but if the machines, smart machines in planes will be clever enough, then these machines will provide options to pilots to choose option 1 or option 2. So it's not so much overcrowding with information. It's possible, again, depending on the solution. Thank you once more.
Yeah, you are right in that. But again, we have to keep in mind that we are talking about flying and flight safety. And if you are letting the machines to do all the work, that is bringing that the consciousness, what is happening around, that happens with the radar, the ATC, has been seen already in the simulations, that if you are just following what happens, how about if something happens now? You have to be able to react right away. So already there are cities where the metro is run by a machine. There is not a human being driving. Okay, but it is only 2-dimensional. It's on the rails. And there is a braking system. If something fails, it starts to brake. We can't do that with aircrafts. So there is a little bit. The scientists say that it is possible to do, but I'm a bit skeptical. I'm too old for it.
About this new technology, when we are talking about the old technology, then we understand this is a discrete model. We are talking about fixed routes, we are talking about fixed flight levels, etc. But now, when we are talking about new technology, then there is a 4-dimensional trajectory, there are these different bubbles, safety bubble, freedom bubble, which seems it's not anymore discrete model, this is probabilistic model. And that means that the reliability for result is not anymore 100%, it's still a bit less, depends on the model. How do you perceive this as a genuine ATM person, and how do you feel how easy or how difficult it is to apply this new model in the brains of the air traffic people? Thank you.
Okay, that was a nice question. The idea, I feel it's so hard somehow that the selection process for air traffic controllers has to be changed. We can't, for my background, I can't do that. I can't see that things are happening automatically. And I have been seen simulations. I have not been part, but I have been watching out simulations where the system is making decisions in a terminal airspace. So basically these new models are feasible in the en route airspace or oceanic airspace. But when we are getting in a terminal where the distances are smaller, where there are climb rates, descent rates, different, can be several airports in the same terminal, where there are plenty of crossings, then I'm a bit skeptical. And I have seen that kind of things computer is proposing and then actually doing actions, giving commands in the simulations that if my students are doing that on my simulations, I would say that you are nuts. Because the calculation capacity for a machine is so much better. They know how the aircraft are behaving, how they are handling. But how about if it doesn't? Once there is something which goes wrong. It's like, do you really trust your mobile phone? That's the question.
Aga läheme nüüd ettekannetega edasi.